Hey everyone! So we're back for this afternoon because I really wanted to get this to a good shape. I originally, this is where we are. Actually, hold on. Let me turn down the music a little bit. Just realized I could probably do it somewhere else. Anyways, so this is where we left off before lunch, my lunch. And it felt really weird to me. Okay, so these I think are, so it definitely felt really weird. What we're seeing, and actually, let me pull up what I have on my iPad. So this is what I have. And so what we should be seeing, actually, I'm quite confused. Honestly, I'm a little bit confused because I'm pretty 100% sure that I messed up on the height calculation. But I thought it was really weird that there's so many with like essentially, oh yeah, because we were looking at the data and I thought it was so weird that we had so many where it was, you know, difference between, yeah, like the margin was 5,000 for the county, and then the rejected number was 8,000 or 80,000. Like that's um like multitudes more. And then I thought it was really weird that this wasn't reflected in the data explorer, and then I realized it was because I had been the way that I was calculating the data, I was essentially limiting it to zero, between 0 and 1. Y is rejected equal to male. So the particular one, the rejected is, it's male ballots rejected. So it's mail-in ballots that are rejected, and then there's also provisional ballots rejected. Although I was thinking of taking out the provisional ballots. Actually, let me do that and see if it changes things. So actually, what would it look like if I did just this? Which I guess is very similar still. Yeah, so yeah, it's rejected mail-in ballots. And even then, yeah, a lot of them are, there's a lot of mail ballots that were rejected, and the margin, wow, the margin is so tight. So I was wondering why it wasn't reflected in the data explorer, and then I realized it's because I was forcing the ratio to be only between 0 and 1, because previously when I was doing the number of voters removed, I was looking at a part of a whole, and so that's why I was trying to force it between 0 and 1, because if it was over 1, that means that there was like data input error. But in this particular case, like number of mail rejected to win margin is not part of a whole, so then we wouldn't want to force it between 0 and 1. And then so once I lifted that, it looked like this, where Lancaster County, Nebraska had like more than 100 times rejected mail ballots than the winning, than the margin of victory. And then, yeah, even, and then I guess the next one is the Olmsted County, which had, I guess that looks like almost 30 times. So, yeah, and also this Hennepin County that rejected 200,000 mail-in ballots. And now everything is like, the scale is, so everything is down here. Actually, I wonder what happens if I look at only the outliers. And then also, I think the box plots are not working right now, and I wonder if it's because I hard-coded the scale. Let's see. Hello to fishermen. And do we have, there we go. There's this. Actually, I'm looking at outliers right now, which is, I guess, still most of them are outliers, I guess. Yeah, so what I wanted to do is now that I see that some of them, the difference is sometimes like, 120 times. I don't think the design I have here applies anymore, because this one I was assuming that it was just like a really small difference between the margin of victory and the number of rejected ballots. But now that I see it's like sometimes, like now that I see that it's like so many times, I'm going to rethink this. And actually, how about we concentrate on the ones with only the ones where it was more than, where the difference was negative, as in like where there were so many more rejected mail-in ballots than the margin of victory. So let's try that. Let's see. Okay, so that, let's make sure there it is. And then let's see if the dot difference is less than 0. And then how many of them are there? 46. 46 counties, where mostly in Minnesota and Nebraska, where so this one is, this chart is displayed in absolutes. Because I wanted to show the scale of the difference. So there's 46 counties. I wonder, for Minnesota and Nebraska in particular, because they're still the top two. Yeah, Minnesota. Wonder if for Minnesota and Nebraska, if the margins would have been enough. Okay, let's look at this. Let's look at, whoa, what just happened? Oh, because we're looking at all of them. Whoa. Wow, that was accidental, but oh, thank you so much, Fisherman. Oh, yeah, you should give it a try. It's really fun. I mean, like, coding and programming, there are definitely extremely frustrating moments, but when you get something working, it's super fun. I highly recommend it. So, this is so interesting. Wait. Okay, so I feel like my code is incorrect. It's definitely not correct. Let me just, let me only do, something is so incorrect. The difference, if it's a negative difference, that means there were so many more mail-in ballots. Let me just do it at, let me do the height. Let me do the height as, no, that height should be correct. Yeah, so the taller it is, it means that, actually, this is what it looks like. So the taller it is, the, yeah, the margin of victory, the more there was margin of, so basically the number of rejected ballots didn't matter. Oh, thank you, Fisherman. So that, the walls, yeah, the About Me section, that one was my old space, my old wall, with all of the posters that I really liked. Yeah, I still have all of those posters, but I moved from that place. Okay, so let me actually look at the margin, the difference by state. And then I need to rethink, this design. Yeah, okay. So, let's do this. Okay, I'm going to use sum by to get the total number of rejected ballots for a state. So that's rejected, and then the margin. It should be okay to just, yeah, add up the margins. I think so. Or should we be looking at the party that won the state and then only adding up those margins? Would that make more sense? The party that won the state and only added up those margins because those margins are what would have swung the state. That would make more sense, right? I feel like that would make more sense. But let me try it this way first. Oh, wow. And then let me also sort that by the difference. Wisconsin. Rejected 0, margin 0, difference 0. Wisconsin. If state is equal to Wisconsin, console.log county. There are many of them, and it says 0 for all of them. Okay. And I guess I can also put in a ratio. And let's see what the ratio basically of the difference. So margin minus rejected divided by the margin would look like. Oh, oops. The ratio. Yeah, I really wonder what is going on in Nebraska and Minnesota. Because the ratio like for all of the others are about, or actually should it be the other way around? Rejected minus margin? Either way. For everything else is about like 90. Wait, actually, hold on. Sort by the ratio. Yeah, for everything else is like more than 95%, where like the rejected ballots didn't even come anywhere close to the margin of victory. But then for Nebraska and Minnesota, they did. I really want to know like what happened in Nebraska and Minnesota. Can we assume wrong data? I don't know. Actually, Eve's code book? Not Eve's code book. Let me see. No, I don't want to assume that it's wrong data, because if it's right, then it's very interesting. Dataset notes. Georgia, Vermont, corrected data. Okay, so that's not relevant for us. Data codebook survey instrument. Statutory overview dataset. I wonder what that is. Oh, it's actually Minnesota and Nebraska. Let's see if there's anything in here that would say anything. Minnesota. All right, so in here, it should have mail in. So what was it called? Mail in. Wait, hold on. So mail in ballots. Mail rejected. Total for 2016 was C4B. C4. No change since 2014. Mail balloting. They don't seem to have. Yeah, they don't seem to have any notes about mail ballots. Oh wait, this is different from. Okay, I'm gonna stop going down that rabbit hole. And what I'm gonna do is take a look at who won. Who won Nebraska or Minnesota? Let's take a look at. So do they do? What I'm currently wondering is like to calculate the party won for a state. Is it total number of votes for so what I'm trying to figure out is like, if I want to figure out which party won for a state, is it simply just a matter of adding up all of the I guess it is a matter of just adding up all of the um, votes for one party versus the other, and that's the margin. Why was I overthinking this? Okay. Do I have the data to be able to do that in this data set? Okay. Okay, so it should be figure out when margin of victory for this at state level. So then what we want to do is const dem margin is equal to sum by counties if party is equal to, oh, not this one. Yeah, if party is equal to D, then use margin, else it's a 0. And for the Republican, wait, that's not how to do this. That's not the way to do this. And then if I subtract them, no, wait. Why do I have to think so hard on this? Why? Okay, so basically, what I want is like Republican minus, basically whoever won minus Democrat or vice versa, and then basically the error margin. Okay, I'm just gonna do it by getting the absolute numbers. Yeah, let's go and get the absolute numbers. oops. Republican votes for that year and Democrat votes for that year. And then here, that way, I can do that. Sum by votes. And then by Republican votes. And then the margin is math.absolute. Okay, now let's take a look. Okay, yeah, so at the state level, are you sure about the variable names? So do you mean these variable names, or which variable names are you referring to, Gilliam? So, wow, in Minnesota. Oh, thank you. But I think that still worked out. Yeah, I think that still worked out. Thank you for pointing it out. Okay, so now we're seeing that the margin was about 40,000 in Minnesota, but the different, yeah, I was consistently wrong between both of them. But the difference, wow, is 600,000. So there were 600,000 more rejected. Well, yeah, so there was 600,000 rejected ballots, and the margin was 40,000. So that is really intense. That is like 13 times more versus this is 10 times more. And then all of the other ones don't have, yeah, the margin was 10,000 and then the rejected was 61,000, for example. So, yeah, whenever we, yeah. Actually, what if I use the difference by state? That's not what I was expecting. Okay. That is definitely not what I was expecting. It's very red. Oh, I guess it's red because so party is if Dem votes is greater than Republican votes, then D versus R. Okay. Why do you look like that? Width is 800. Where? Because we don't have a FIPS code here. And the FIPS code for a state is just the first two characters. So I can go and get the substring. And get 0 to 2. That should be the FIPS code. Is it like that? Get substring. Oh, dot FIPS code. Okay, so it is So actually, Minnesota and Nebraska are down here, and then this is someone towards the very bottom. This is wow. This is like overwhelming. Like this is like 29 million. The margin was 29 million. And this margin was 5 million. So this is probably the 29 million. That was Massachusetts. So now I feel a little bit, now I feel uncertain about how to go about this. Okay, so main story. Oh, here. So the story potentially is that in Minnesota there was what? That was really random. My husband just brought over from the garage downstairs. This is one of my projects from, I guess, almost 2 years ago. And then last year when we did a studio show, I framed it. And then it's been in the garage because I feel weird about putting up my own work in our home. So it's been. Oh, I see. Yeah, I don't know what to do with these. But I guess now it's up here. Just like came by and then dropped them off on my desk. Okay. Yeah, these are the crystals. So we did a studio show where we did like kind of like a last year in 2019 we did a studio show where we did a kind of like a retrospective on 2018, and so like we put up some of our work from the previous year. Yeah, this is another one. I don't know why I'm holding this up in this like small screen here. Then you can see this better. Yeah. So that's what that looks like. It's in a nice, pretty rose gold frame. This is the other one. I really like this like overhead shot of the data set. If only I can make something like this right now. Maybe it's because it's the end of the week, but I currently feel so frazzled and so drained, creatively drained. But, oh, thank you, Nerdy Curious. I especially like the, I really like the colors in that project too. Oh man, I don't know what I want to show. What do I want to show? So I'm trying to say that Minnesota, like having a mini tiny like this is basically what I look like when I don't know. Right, Minnesota is like there's 13 times the number of rejected ballots to margin of victory. And then there's like, you know, a 10% like, and then there are about 46 counties where rejected ballots were more than the margin of victory. So I do think, because there's only 46 of them or so, I think we could concentrate on what's the story you shared, Gilliam? Oh yeah, that is the story of how I created those crystals. I'm pretty curious. It's Friday. I feel you. I feel you too. I just want to get this out. I just want to get this design done so that we can publish it next week. So I feel like I'm the type that like coding deadlines are perfectly fine, but like design takes me so long. And so having like a deadline for the design is really hard for me. Okay, but I think I want to be able to show these 46. And then I want to show the multiplier. So basically the ratio here. And you know what? Let's just, should I do? Oh, I do have the margin. So margin. Oh, thanks, Gilliam. I forgot to switch back to the code. There we go. Okay, so difference is margin minus rejected, and then let's get the ratio is difference divided by margin. Yeah, that looks right, right? Yeah, difference divided by margin. So, and then I'm going to take a look at the ones with the biggest ratio. And those were, yeah, so this Nebraska place, that was like 110. There's actually, yeah, let's see. So where the ratio is bigger than 1, or yeah, the difference d and d dot difference is less than 0. And that would be 46 of them. Maybe it is. Yeah, I think I want to show the absolute numbers. So what I'm trying to determine right now, like what I'm trying to think through is whether I want to show this ratio where it's like some of these are, 110 times. But I feel like that's like so many jumps for someone to make. Like for someone to have to make. I think the difference one would be much easier to grasp. So, like the ratio is nice to get a sense. Okay, I'm mumbling to myself. So let me redraw the design, and it's going to be very similar. So I think the design I have in my mind it's like very similar to what we were working on before lunch. With like a tiny difference, which is that it's going to be like flipped. So what I mean by that is it's going to be, here's the axes, and then it's going to be let's say yeah, I think this is it. Yeah, I think this is how we can do the story. So basically, it's like essentially it's like more potential for swinging the result, because this up here, oh no, this whole thing is number of rejected ballots, and this is the margin of victory. As in, like, if we applied all of the rejected ballots to the margin of victory, like the above is the leftover, like kind of like the leftover like, yeah, like quote unquote, like the leftover ballots. Like it could have completely swung the result in either direction. Thank you for the vote of confidence. Yeah, I think that has a lot of potential. Okay, so let's do this. And I think it's pretty easy to see, and it just needs to be labeled well. Okay, so need to change around the scales a little bit. This is obviously not what is going on there. Let's do rejected margin difference. Yeah, so that is not calculated correctly, though very interesting looking. And actually, I think what would be interesting is if I color it by the state. Yeah, let's color it by the state. Oops, no. So let's get a color scale. Is equal to scale, wait, categorical? D3 scale chromatic. Yeah, let's for now use, let's use scheme category 10. I'll use scale ordinal and then use d3.scheme category 10, and then later on I will make my own colors, which is always fun. Make my own colors. Sorry, I mean choose my own colors. No, I will not be making my own colors. Just like grab some paint and then like mix colors. Okay, so I want to use D3 scheme category 10, and the domain is all of the states. So map the state. And then here I can say color scale d.state. And that makes sense. Most of them are Minnesota or Nebraska. And then we need to fix whatever is happening with this Y scale. What is happening with this Y scale? Okay, so I was saying, okay, now that is the number of rejected ballots. So, well, I think I need to, yeah, so I think the Y scale is correct. It's that my height, no, my Y scale isn't correct. So, okay. I'm gonna do almost getting there. Got there. Yep. man. I'm not sure what to do now. Actually, I was wondering about like the dimensions of an Instagram post. Hello, Lukba. Hello. Have the same lower bound. Good question. Very good question. That does look very suspect. And the way we can tell is if we increase the height. Yeah, there we go. So that is not what's supposed to be happening. So I think I'm definitely still doing the math wrong. Instagram size. Okay, so I want to be going towards 1080 by 1080. Wow, there's Insta stories too. Aspects for Insta stories. 1080 by 1080. I mean, I guess any square is fine. Now I think about it. But let's just say the size. You know what? I'm making 960. Actually. Alright, so I'm definitely doing this math wrong. Okay, so what I want is the difference above and the okay, I know what I need to be doing now. Okay, so essentially what I need is the max y is equal to the max difference, and then the minimum y is equal to the negative maximum margin of victory, and then the height for each one is essentially and then the height is this one minus this one. Yeah, that makes sense. All right, I needed to write that out. Okay, so basically this one minus this one. Perfect. Okay, I have a plan. Max difference. So max y is max y the max difference or the max rejected? No, it's the max difference because so essentially there is it's the max difference. No, wait. Because this up here is okay, now I'm lost again. So this up here is a difference. Yes. And then me too, I'm really lost. So MB of rejected. What's MB? Oh, number of rejected? So this entire bar is the number of rejected ballots. And then no. I think that makes sense. So because so this entirety is the number of rejected ballots, and then everything above is the difference, and then everything below is the margin of victory. And the reason why we can't just get like the positive y was about rejected. No, it's essentially this whole bar is a rejected ballot, and then it's basically like if you think about like if you think about a bar that represents all of the rejected ballots, and then you shift it down by the margin of victory, and then so that's what's happening. So positive y is the number of rejected. Is that too abstract? The number of rejected ballots that I'm gonna try this and then see if it actually works in terms of story, or if it's too convoluted. Okay, I'm gonna try. I'm pretty sure that in terms of the y scale that will work. Okay, so maximum difference. So the lowest point is the the maximum margin, and then the highest point is the maximum difference. Yeah. And then to calculate the height, it's the bottom here is minus the margin minus the difference. Okay, let me see. Okay, yeah. So this, I believe, is correct. This is correct. So let me try and explain this in one sentence. So everything up here, everything in the positive y axis, or everything that's a positive y, is the number of rejected ballots left over even after applying even after like filling in all of the margin. That makes no sense as an explanation. I'm trying to capture trying to show both. Yeah, but I feel like I don't have the luxury of two graphs in an Instagram post. Well, this is essentially a stacked bar chart, right? Like, um, it's just that this side is like, yeah, it's essentially a stacked bar chart with like an offset, because it's essentially that this is the margin of victory. Like, this below is the margin of victory, and the yellow is the difference between the number of rejected ballots and the margin of victory. And I feel like I just need to figure out like how to describe that better. Like, like this is basically saying like, look at all of these leftover ballots, like quote unquote, like leftover. Like, they could have been, like, essentially they could have completely changed the result. Yeah, I think that's what I'm trying to say. Like this is basically where we don't know. Like, these are essentially like gray ballots, right? Like we don't know what they could have been. Like, they could have been anything, and they could have completely changed the result. Yeah, so right, so yeah. So Smash J1 says you're trying to show parts of a whole, right? If the total rejected ballots, this menu could have swung the vote. Yeah, exactly. Could have swung the vote. Um, Although that's not 100% true, because like you could have, because like this is assuming that, you know, everybody here would have voted. Yeah. Yeah. This is basically, this is the potential to have completely swung the vote. And the reason why I'm putting it like this is so that it's easier to compare, like, kind of this side. I feel like this is if we just have like the message, like if I just get the message correct, then I think, yeah. Sorry, the gap above? You mean like, sorry, what do you mean by the gap above? The margin isn't the story, it's the gap above. Yeah. So the margin is not the story, it's the it's the yellow part above. The yellow part is the yellow part is the story. Essentially, it's like, look at this many number of rejected ballots. Like, they could have been anything. Actually, I'm curious to see this for curious to see this for the other states. Let me look at this from the state level. Ooh. Oh man, look at that. Actually, you probably can't see anything right now. But there's like very, very faint, like 5,000, essentially like 5,000 points being drawn right now. Where there's some that go really margin. Some of them, the margin of victory is really big. But I'm gonna do filter. Yeah, I think you're right. I think I'm just trying to force something, and I think it's making it confusing. Like why the margin should be counted within the rejected. Like I think it's so. What I'm trying to figure out is like it's not. Yeah, I feel like I'm not doing this in a very it might not be at once intuitive. Well, I guess the question is, like, I mean, I think it does make sense to put margin within the rejected because it's pretty much like saying, like, let's pretend that all of these rejected ballots, like, let's pretend that, like, we applied, let's pretend that this county was red and like it had like 400 ballots, or like it was like a 400 votes margin of victory. Let's go and apply like 500 of these rejected ballots to and pretend that they were blue so that it like offset these 400 votes. And then the rest could swing it in any way. Did you filter on counties where the margin was less than the rejected? Yeah, I filtered by that. Let me look at it from the state's perspective. So, from the state's perspective, sort by yeah, I feel like there's like I feel like it could make sense, and I feel like I'm just going about it in a very convoluted way. Like what I'm trying to get across is like, look, these rejected ballots, like they could fill up this margin of victory and then even more. Um, and trying to like, yeah, so like basically, I don't know, you could fill up these and then even more. Actually, I think what would be great in terms of like actually visually to try and get that point across is like, let's make, like, let's just say that each, I love that you all are basically like my um, litmus test of like, does that make sense? Am I just like trying to make it too complicated? And also just keep on speaking until it like makes sense to everyone. So all of this is like, let's say that, and then everything above is the gray because like we don't know what it could have been. Like, let's say that, like we made each of these so basically, yeah, so basically this whole thing is the rejected ballots. Now let's say that I like applied, like basically apply like this part is like if you apply some rejected like apply, like let's say, let's pretend these rejected votes were actually like no, Gilliam, I feel like it's not you being dense. I think it's me being overly complicated about it. But I do think that like it takes explaining, so it like takes good annotation. But I think if explained well, then hopefully it would be very intuitive. And even if it's like, even if this part, the margin part, is too hard to explain, the most important thing is that like the y is, or the positive y is supposed to be essentially like if nothing else makes sense, then it's that the like positive y is like, it could be anything, like it could really swing the results. I am so not good with words, but I'm gonna go forward with this visual and then hope that we can come up with much better explanations than I am. So yeah, basically the no smash it is, the positive Y is all rejected ballots minus the margin of victory. So this one is total rejected ballots. So basically, I guess another way to think about it is like this line is like the equilibrium. Is that spelled? I feel like I spelled that incorrectly. Like equilibrium. Um. Ooh, so I guess. Ooh, I did spell it right. Equilibrium. So, ooh, I think another way I can explain this is, this line, like, basically, this is the total number of rejected ballots, and then everything below in the negative is needed to bring the votes like 50-50 between the parties, and then everything above is it could have swayed things any way. And I just realized that I'm assuming a two parties, but there are third parties. There are small third parties that we're gonna just ignore for this, for the time being, for like right now. For now, we're just going to ignore. But yeah, okay, so this line, you can think of it as like, you know, like at this line, it's we are now, the two parties have equal number of votes, and then so everything above is it could sway things anyway. I'll keep working on it. Okay, but I will share this. I think will be fun, and that would be, I'm gonna do some, I'm going to make some patterns. So instead of a color scale, I'm gonna make this all some sort of yellow for the fill. I'm gonna give a little bit of padding too. Okay. That is very yellow. Okay, that is like hurts my eyes yellow. Okay, that is not the yellow I was expecting. Is that the, oh, that is that yellow. Okay. All right, we'll go with that. Okay. So now on top of that, I'm going to draw some tick marks. Which is, I need something called texture.js. then I'm gonna use maybe which ones should I use? Okay, I'll just start with textures dot lines, and then I'm going to use. Okay, so then how you do this is, where is it? So this is one of my favorite. There we go. So this is one of my favorite libraries, because it basically lets you do patterns and textures in SVG really fast. So I think, let's see. Let's do it in here. Actually, I need to import textures. I think I just say textures is equal to the texture dash JS. Just textures. Do stroke. Yeah, stroke is, yeah. So I'll say now I'll do hello, finitely generated. What a great name. So I am basically trying to get these patterns and these kind of like hashes onto my bars. That's what I'm trying to do right now. Now, should be able to say, now what I want to do is, okay. So I'm going to make a group for each bar. I'm going to translate it to where it should be on the x coordinate. This one, but do nothing on the y scale. And then I'm going to, for each one of them, set the width. And so let me draw the difference. And that be bars append a rectangle, and then, yeah, and then the height should actually just be the difference also. And the fill, I'm going to do patterns.gray.id, I think is what I want. .url. Patterns. Like finitely generated. Here for the hashes. Me too. So now you see no hashes. And that's apparently because a negative value is not valid. Why would it be a negative value? Because actually height should be y scale 0 minus y scale of difference. Still not here. And I'm console logging something, which probably is slowing things down. Where am I console logging something? There. Okay, let me see why. So there's definitely the pattern defs. The SVG patterns are being created. So that's right. For each G, I wonder if I have to, the height is there, the Y is there. Actually, so it might just be that I cannot actually set the width on the group, and it needs to be set on the rectangles, which actually makes a lot of sense. Actually, so for each of them, I'm gonna have a fill. Let's give it a fill. Where are they? There we go. Oh, silly me. So it's thicker dot fill. I didn't do any of the colors. RGB 225 0, and then stroke. Let's just say the color. Is that not in textures? Is that not the? Oh, background. It's background, not fill. Okay. Background. And still no. Oh, because I hadn't moved the width down to the rectangle yet. Huzzah! Look at the bumblebees! That's disconcerting, but at least we have it now. And then, ooh, finitely generated, so I'm about to embark on a project. We used to have canvases and just redraw when state changed. Okay, and then now draw a margin. So I'm not 100%, I feel like there are so many different definitions for the word canvas and state. This is so funny. That makes so much more sense now that you've clarified. Thank you. But I've been so deep into this like election project. When you said canvas, I thought it was like canvassing. Like, I guess, I don't actually know exactly what K means in the context of an election. I feel like it is a term used in like elections. And when you said state, I literally thought you meant like a US state. And I was like, huh, like something about canvassing and redrawing when a state has changed. But now that you've clarified, makes so much more sense that it's about HTML5 canvas and then redrawing when data state has changed. So D3 is a JavaScript library, and it's actually web technology agnostic. You can use it for SVG, you can use it for Canvas, you can use it for HTML. I don't think you can use it, no, you cannot use it for WebGL. So I would take D3 out of that versus. And for Canvas versus WebGL, I very rarely use WebGL unless I'm like trying to deal with 3D, like trying to draw and render in 3D. So like I've never like I think maybe you might touch on WebGL for like performance reasons if you have like millions of points that you want to render, which is probably not that often. And so I would say like usually I don't use WebGL either. And then it's a difference between SVG versus Canvas. I use SVG when like it's a pretty small project without that many data points, and just easier to get started for me personally. That's when I use SVG, and then Canvas I'll use if so like SVG I might use for like prototyping too. And then Canvas I'll use if I have like a lot of data points that I want to render, and it's really good for performance. And then I used to use React. I now use Vue. I mean, I've kind of and then Vue I prefer just because I feel like it plays much more nicely with like creating data visualizations. Okay, let's draw the margin. So this one is gonna be going below, so negative d dot margin, and then the height is going to be negative d dot margin minus 0. And then this one is going to be so I messed up on the y. The y should actually be just y0. Actually, I calculated y0 already, so I should use it. Y0, and then y0. There we go. So I don't think yellow is a great color for this. It like makes me feel so alarmed. Yeah. So let's not do yellow. Picture lines, thicker. Let's do like, also let's not have it be so thick. Maybe. Yeah, let's not have it that thick. Well, my alma mater colors is yellow and blue, so I have a particular fondness for it. But oh, hello, Hugo! It's been a while. Thank you for joining the stream. I know that it's like really late for all of you over there right now, right? I know I'm now keeping Gilliam up because it's probably, oh my god, it's probably past 1 a.m. for you. I'm sorry. I'll end this soon. Funky Badger, but oh yeah, it's the weekend. You're right. Well, happy Friday, happy weekend. Funky Badger but asks UCLA? Question mark. No, my alma mater is Berkeley. Very close guess. So not a fan of these colors, but it's not bad. actually, it leaves a lot of really good space for annotation. So here's the fun thing I learned in my most recent client project. Oh no, why do you keep opening up 2019? First quit. Okay, Illustrator 2020. Yeah, okay. The fun thing, maybe make it more prominent than the gray. Make the red and blue more prominent. Oh, love to hear your thoughts on why. 1 a.m. in Basque Country. Oh, thicker, actually. Yeah, let's try heavier. So, still haven't quite figured out Texture.js and like its naming scheme, because I'm guessing when you say thicker, you mean like the bands are thicker, but like in here, in Texture.js, thicker means that they're like more compacted, which I think actually makes sense because it's like thicker versus thinner and heavier versus lighter. So let's give that one a try. Yeah, in terms of boldness. So you get heavier. Ooh, I just think the yellow is a bad background color, so I'll change it to something else. Yeah, the yellow is a mistake. I was gonna show because I think that's all of the wow, look at that one. Okay, now this is the fun part. You can copy, so I just copied the SVG, and then you can open a new thing. Oops, not open. No. Create new. I want create new. And then go web. Ooh. Is there like Instagram? Wow, there's an infographic element set. Common. Is there like a social media one or something? Can I get like an Instagram one? Here, I'll make an Instagram one. Instagram. 1080 by 1080. Yeah, great. I need to figure out like a good color that would work well with all of those. Then I can just paste it in. And now I can work in Illustrator to annotate everything so that it's much faster. But I need to, now I'm just having fun like minimizing and maximizing. Okay, anyways, now then it's like much faster for me to like annotate all of these elements. But I can't go forward in Illustrator until I've changed the colors around, because it's kind of hard to change. So once I have, like, I don't know Illustrator that well, so I guess it is that I can also change around the colors in Illustrator, but I'm not very good with like patterns and stuff in Illustrator yet. So one last thing I'll do, I will mark them with the abbreviated state. So where, there we go. Information. Oh man, I'm starting to like feel myself crash. So after I do that, I'm just gonna wow. Okay. So after I do this, I'm just gonna log off. And then here, put in state abbreviation. Text. Oh, Gilliam, that's such a good summary of the chart. Okay, so wow, really crashing. Okay, I can do this. Let's put it. Oh. Yeah, I think I wonder, like, did the fact that did the colors, the different colors really help? Because I noticed that you are explaining via the colors. It seems like the colors helped. I think my switches are red. I can't remember. I think my keyboard switches are red. Yeah. Ooh. Dang. Fun. Okay. So, what I just decided is that I'm going to color each of these bars by the state. Actually, I think let me actually make it, yeah, which means I need to come up with a few different colors that work well with gray, red, and blue. And I'll also change the actual colors for red and blue. So I'll work on the color palette. So this particular chart is an evolution over time. This is just the 2016 election. But we have been looking at some other parts of the data set over time. So, but this particular one is just number of rejected mail ballots in 2016 for specific counties and then like how they could have potentially, yeah, swayed things. Actually, let me bring the color scale back. Okay, this is the last thing I do, which is what I said. That's what I said the last thing I did. Yeah, this is gonna be actually the last thing I do, I swear, I think. And then ooh, well then, that's fun. Look at all these colors. Are mostly Minnesota and Nebraska for some reason. So this is the counties where the number of rejected ballots was more than the margin of victory. Yeah. Okay, I'm gonna keep working on the annotations for these, like actual copy of the annotations for these. Attribution is always a tough one, though, so perhaps no definitive conclusions. Oh, you mean like which way it could have swung? Yeah, I agree. I mean, like we don't know, like we don't know, like we essentially don't know what any of these ballots, like which way they were voted. Um, Although I suppose if we actually look at like party registration, like voter registration for party, because like you do get those numbers, so we could probably actually make a good guess. But I think the main thing that we want to get through with this one is being like your vote really could matter, at least in your county. So make sure that you're doing everything you can not to get the mail-in ballots rejected, or like your mail-in ballot rejected. I feel like figuring out what party a voter is registered with for each county is something I want to do, but that's a rabbit hole, and I think I'm already going down too far. Just like trying to keep these like easy to look at a glance. Yeah, so gonna work on the labels. I wonder what this would look like for the states. I'm not gonna do that. Yeah, I'm not gonna do that. I'm done. I'm done for the day. Oh my god, it's been 2 hours. Okay, yeah, for sure. This stream is done. I've streamed almost 4 hours. Like we're thank you. um, for this, my remaining to-dos is colors and then annotate. And then actually wondering if there's I actually wonder if this would look better if it's like rotated 90 degrees so that it stands up. Like where it's basically like on this side is like, you know, let's say that, okay, thinking too much. I'm gonna stop it here. Yes, I'm gonna stop it here. I'm gonna take some notes. Like, I'm just gonna take my, like, what I have left to do's. And then I'm gonna end the stream because it's been like 4 hours. So you don't need any more of this. Okay, so the to-dos are colors, prettier colors. Colors matter a lot, annotations. And then flip it 90 degrees so that it like the equilibrium line goes this way. I think that might actually, maybe that gets the point across more so that it looks more like, so it looks more like that. And something to think about, something to try out later after a break, after a brain break. Yeah, definitely something to try later. So yeah. Oh man, thank you everybody that encouraged me. Today there was definitely like sometime around 240 or 50 where I was just like in a real slump. And I was like, oh God. So thank you for helping me push through. Oh, thank you, Hugo. To see such data and dataviz create, bringing this to life, exciting because meaningful topic. Yeah, definitely. I did not know that I would see something so interesting. And yeah, thank you everybody. Oh man. Wait, hold on. Yeah. Gilliam, you're right. Like if we flip it 90 degrees, then there wouldn't be a bias towards positive or negative. Yeah, I think you're right. So like, yeah, something along those lines. I think there's real potential there. I'm saying this for too long. Oh, thank you, Nerdy Curious. Okay. Okay. Thank you to everyone that stuck around, especially if you stuck around for all 4 hours of today's stream. That was extreme. But I'm so glad to get it to the shape it is now. Thank you for all of your feedback to help get it to this shape, and kind of like letting me bounce off of you, like if it actually makes sense or not. And I'm glad that it seems like it does. It seems like it does make sense. So yeah, see you next time. Unless I decide to do an impromptu session, I will see you next Wednesday. And have a great October weekend. It's fall. I love fall. My husband earlier today was like, ooh, I found some maple syrup cookie, like sugarless cookie recipes. So excited. Love fall. Okay, bye-bye. Have a great weekend.